building steel ground should be bonded to the neutral bar in the main service equipment. This is in accordance with National Electrical Code Section 250.24, A5, which pertains to grounding requirements. The purpose of this bond is to ensure a low impedance path for fault current, facilitating the operation of overcurrent protective devices. This bond connects the grounded conductor, typically the neutral, to the building's metallic structure, creating an effective ground fault current path. Now, concerning the use of greenfield, it should not be used as a grounding conductor. National Electrical Code Section 250.118 outlines acceptable grounding and bonding conductors. Greenfield, which is flexible metal conduit, is not listed as an acceptable grounding conductor. A separate equipment grounding conductor must be installed within the greenfield to provide a reliable ground fault current path. The flexible metal conduit itself is not designed to carry fault current. Moving on to the 30 kV transformer. A 125 amps main breaker is not the correct size. The correct size should be 100 amps. This is determined by National Electrical Code Section 450.3 B, which governs the overcurrent protection of transformers. To determine the maximum allowable overcurrent protection for the secondary side of the transformer, a calculation is necessary. This calculation ensures that the transformer is adequately protected from overloads and short circuits. According to the calculations, the secondary calculation presented is correct. The secondary current calculation is as follows. First, calculate the secondary current of the 30 kV amps transformer. The formula is transformer kV amps multiplied by 1000 divided by the secondary voltage multiplied by the square root of 3. With a 30 kV amps transformer and a 208 volts secondary, the calculation is 30 kV amps times 1000 divided by 208 volts times 1.73, which equals approximately 83 amps. Now, to determine the maximum allowable overcurrent protection, you can apply the 125% rule as described in National Electrical Code 450.3 B. Multiply the secondary current by 1.25, which in this case is 83 amps multiplied by a 1.25 equaling 103.75 amps. Then determine the standard overcurrent device rating. Referring to National Electrical Code Section 240.6, which lists standard ampere ratings for fuses and circuit breakers, the next highest standard size overcurrent device is 110 amps. Therefore, a 110 amps breaker would be permitted. But the question described a 125 amps main breaker that was being used. According to NEC Section 450.3 B, for transformers over 600 volts nominal, the overcurrent device must be set at no more than 125% of the rated primary current of the transformer. If the primary current is 9.62 amps on a 2400 volts primary system and you have a 15 amps breaker installed, this complies with the code, but you are not permitted to have a breaker that is 20 amps installed. Secondly, for transformers of 600 volts or less, the code requires the overcurrent protection to be no more than 125% of the rated primary current. For example, with a 480 volts primary and 208 volts secondary, 75 kV amps transformer and a primary current of 90 amps, you would use a 125 amps breaker, which is the next size up from the calculation. The next size up rule comes from NEC Section 240.6. Say, the standard ampere ratings for fuses and inverse time circuit breakers are 15, 20, 25, 30, 35, 40, 45, 50, 60, 70, 80, 90, 100, 110, 125, 150, 175, 200, 225, 250, 300, 350, 400, 450, 500, 600, 700, 800, 1000, 1200, 1600, 2000, 2500, 3000, 4000, 5000, and 6000 amps. Intermediate ratings are sometimes available.